Hello guys, welcome back to MJ School of Mining and Geology. In today's session, we are exclusively focusing on the vertical exaggeration that is widely used in the map work, usually in the geography, and also what you call it, the structural geology. Please stay tuned. But above all, don't forget to like, share, comment, and hit the notification button below so that you get notified once we upload new content. Stay tuned and enjoy the lesson. Well, the vertical exaggeration, or known as a VE, is used in geography, structural geology, and cartography to show the terrain features more clearly. And so, when those features that are shown more clearly, they're shown more clearly by what? By exaggerating the vertical scale compared to horizontal scale. Because if you don't exaggerate them, those the features they're gonna appear they are they're not going to be clearly visible. They're going to appear flat. So we exaggerate the vertical scale so that mountainous regions or the hills, they can clearly be visible. And we apply this formula, which is VE is equals to sorry about that, VE is equals to vertical scale divided by the horizontal scale. So why do we use vertical exaggeration? So if you can clearly see over here, you'll agree with me that the terrain over here is drawn to scale. And if it's drawn to scale, and that is to say it's not well exaggerated or is not exaggerated, it means this will appear to be flat. But if you exaggerated the vertical scale, then you make sure that now the hills and the mountainous regions, they clearly get to be visible. So in the in the real life landscapes, like hills and valleys are often wide compared to how tall they are. All right, they are often tall. They are often wide compared to how tall they are. So what we mean is these are really they are wide. They are wide as compared to how tall they are. So if we draw them to scale, they would look almost flat like this. Okay, this is when these features were drawn to scale. That's why they look almost flat. So we need to exaggerate the height to make these terrains to become easier to see or to become visible. All right. So then we ask ourselves why it can be hard to see terrain features, because the horizontal distances are usually much larger. So the horizontal distances, these distances are usually much larger. So when compared to these ones, all right, as compared to vertical heights. So it means now that with that being said, if we were to draw these terrains to scale, they would often look flat. All right. So that's why now we need to apply the vertical exaggeration to make hills, valleys, and mountains to be more visible. All right. I hope you are following. And then now, moving right on, train drawn to scale. I want to expand that knowledge that I've just mentioned. So the horizontal and vertical dimensions of the terrain are represented accurately and proportionally to their real world sizes. That's when terrain is drawn to scale. It means the dimensions, they are accurately and proportionally represented, right, to their real world sizes. So if a map or a diagram is drawn to scale, it means that, for example, 1 centimeter on the map might represent 500 meters in real life. That is the horizontal scale that I've mentioned, that the horizontal scale they are much wider. But 1 centimeter in height might represent 50 meters in real life. Now, we already mentioned the fact that the horizontal distances are much wider than the vertical distances. So now this keeps the true proportions of the landscape. So if a hill is gently sloping in real life, it will look gently sloping on the map too. All right. It would look gently sloping on the map too. So that is the idea that I want to bring to your attention. Now, the question says, let me clean this. Let me clean this first so that we can calculate this. All right. So the question says we should calculate this vertical exaggeration, and I'll also explain what the answer means. But one thing that I want to bring to your attention is before you could do anything, always step number one, you must try to convert the vertical, you must try to convert the vertical scale to a ratio. You must always try to convert the vertical scale to a ratio. So it means we need both scales in the same format or in the same ratios. Both the vertical and the horizontal scales, they need to be in the same format. So here you see that on the horizontal we've got 1:50,000. So it means we can keep this one and then now try to convert or make this one to be in the this vertical scale to be a ratio, so that these things or these scales, they are in the same dimensions, or rather they are in the same format. All right, so it means the first step, we would need to convert this 20 meters to millimeters. All right, so we'd say we know that uh, 20 meters um, is equal to 20,000 millimeters. All right, so we converted this 20 meters into millimeters. Now, so now the vertical scale becomes now vertical scale would now become 4 millimeters. It is to 4 millimeters is to 20,000, or for 20,000 millimeters. All right. So that's the conversion. Now, then, if we're this is a very large number, we can still simplify by dividing both sides by 4. And then now you would get 1 is to 5,000. Now 5,000. Now it means now we can easily now start to plug in these values from the formula. um Now we know that the formula says vertical exaggeration is equals to the vertical scale divided by the horizontal scale. So it's the same as you saying the vertical scale divided by the horizontal scale. But let's plug in now our ratios. Vertical scale, what do we have on the vertical scale? We have got 1:5,000. So it's 1 divided by 5,000, because the ratio means divide by, and then we divide the sign, divide by horizontal scale, which is 1 divided by 5 or 50, sorry, thousand. All right. Now, the what we call application is done. The application of the formula is done. Now, what is left now? It's what we call the mathematical gymnastics. Okay, so in mathematics, we have learned that once you convert the division sign into a multiplication sign, you swap or you invert these things. So it means 50,000, it would be on top, and then 1 at the bottom. So you say 1/5,000 multiplied by 5,000 divided by 1. All right, if you replace a division sign by multiplication sign, you swap these things. All right, so now you will say 1 times 5,000. This is like 1 times 5,000. So this will be allow me to write it like here, So this thing is like now 1 multiplied by 5 or 50,000 divided by 5,000 multiplied by 1. So it's like now it's like 50,000 divided by 5,000. And if you press that on your calculator, you will get nothing but 10. So it means now that our vertical exaggeration is 10 times. Our vertical exaggeration is 10 times. times. But now, we want to understand what does this 10 times means. So this 10 times means that let me change the let me change my pen. Let me change my pen to black. Yes. So this means that the vertical scale all right, vertical scale, it could be the height or elevation, in the diagram or the map is 10 times larger, is 10 times larger than the horizontal scale. Or if you don't want to say this, the horizontal scale, you can say distance, I'm sorry, distance across across the ground across the ground. So that's this 10, what this 10,000 or not 10,000 but 10 times means. So like I said, that the landscape such as hills and valleys, they are often wide compared to how tall they are. So I've mentioned that if we were to draw this thing to scale, then these features, they were gonna be almost flat, but we exaggerated the height to make them much easier to see. All right. So I hope this calculation makes sense. I hope this calculation makes sense. And now I want you to imagine this now. All right. I think we can wrap these answers. We can wrap these answers. Sorry about that. Our screen looks so messy. I want you to visualize this. All right. I want you to visualize this. So here I'm comparing the two cross sections from A to B, wherein no vertical exaggeration has been applied, and the other one wherein we have got the vertical exaggeration of 10 times, the one that we just calculated previously. All right. So looking at this, you would agree with me that when vertical exaggeration is not applied, the features they apply almost or they tend to be seen almost flat. All right. So, up here, you imagine you looking at a hill that is, for example, 500 meters wide. Just give you an example, and for example, 50 meters tall. I've already mentioned the fact that the horizontal scale is usually larger than the vertical scale. All right. So it means now, if you were to draw these to scale, the hill would look like a tiny bump. So you see, this would be a tiny bump, all right, because this was drawn to scale. But now, if you were to multiply the height by 10, so by 10, it would become it will become remember, you'd have 500 meters wide, and then now this 50 times 10, it will still be now 500 meters tall, because you multiply that by 10, which is exaggeration. Now it looks like a steep mountain. Now it will look like a steep mountain that is much easier to see and to analyze. That's what the vertical exaggeration is all about. I hope this makes sense. All right. In real life, you see here we have got no vertical exaggeration that has been applied. That's here. All right. That's here. all right, wherein we have in something that is 50-meter tall, all right. So it means these terrains, they appear to be almost flat. They are not easier to see or to be visualized or to be analyzed because no vertical exaggeration has been applied. But once you apply the vertical exaggeration, you multiply your height by a certain number. Now these start to be easily to be seen, all right. They start to be visually easier, or they start to be visible in actual sense, all right. I hope it makes sense. So sorry, yes, I hope this made sense. This would bring us to the end of our lesson. This was a quick look into the vertical exaggeration that can be applied in cross sections, or basically map work that are usually used in geography or in structural geology. Okay, so I know what you or you know what I'm about to say. That until next time, cheers.